Hello and welcome. Let us discuss on the mitigation pathways, particularly in this week, the 6th week, we are going to discuss about the various mitigation options we have. In last week, that means the 5th week, we discussed about the adaptation options, 4th and 5th week, and this week we will talk about the various mitigation pathways. So, to discuss about the mitigation pathways, we have the following concepts that we will be covering, and this lecture number 26 is more of a broad overview or a general overview as far as the various mitigation pathways in offer as far as the in order to mitigate or deal with the climate change. So, coming to sign. So, first is we have seen or the civilization has seen some sign of progress, some indication of progress, but there are still lot of challenges that lies, and impacts on emission, opportunities and mitigation. There have been various impacts on emission, and we also have various opportunities as far as mitigation is concerned. And global net anthropogenic greenhouse gases emission range we will discuss, and the mitigation and development pathways. The first is transition. So, we have moved, or there have been lot of progress as far as moving towards or transitioning towards a low carbon, you say low carbon economy, you say low carbon production system, low carbon energy system and everywhere. So, transition to a low carbon. So, what do you mean by this? The transition to a low carbon economy depends on a wide range of closely intertwined drivers and constraints that includes policy and technologies. So, we have seen that there are notable advances over the past decade, and that has actually opened up new or large scale opportunities for what you say large scale decarbonization, and this actually in turn offers alternative development pathways that can deliver multiple social and developmental goals. Second, accelerating the mitigation to prevent dangerous anthropogenic interferences with the climate system will require the integration of broadened assessment frameworks and tools that combine multiple perspectives. So, to accelerate the mitigation that would leading towards prevention of dangerous anthropogenic interference in the climate system, it needs integration of broadened assessment frameworks and tools and combine multiple perspectives, so that it will also it can also be applied in a context of multi-level governance. So, this is a must in terms of accelerating the mitigation, multiple perspective, multi-level governance and integrated approach. The third, the speed and direction, or you say the speed and direction and depth of any transition will be determined by choices in the environmental, technological, economic, socio-cultural and institutional realm. So, this is what we say integrated multiple or multi-sector approach. So, the speed, direction and depth of any transition will be determined how well coordinated efforts are coming from environmental, technological, economical, socio-cultural and institutional domains. The fourth, achieving the global transition to a low carbon climate system and a sustained world require purposeful and increasingly coordinated planning. As we have been discussing, it needs coordinated and multi-sectoral and integrated planning, and the decisions at many scales of governance including local, national, subnational, regional and global. So, what we trying to say through this, that yes, the transition to low carbon system needs a coordinated effort across scales, across domain, across group, at multiple level, at multiple scale. Next, greenhouse gas emission slowed down in last decade. It is really good news. So, look at this particular figure. If you see the figure on the y axis, it is the greenhouse emission in terms of gigatons of carbon dioxide equivalent per year. Okay. So, we take all other gases in terms of their equivalent as far as the global warming or their warming potential is concerned, right, and compare it with carbon dioxide. So, probably we have not discussed it, but I can just put it here. So, as all of us know, in terms of global warming potential, 1 unit of methane is almost 21 times warmer than of 1 unit of carbon dioxide, and similarly nitrous oxide 210 times warmer. So, we compute many other or all other greenhouse gases as far as their global warming potential is concerned in the coin or at the coin of carbon dioxide. So, carbon dioxide is used as a coin for calculating the global warming potential of all other greenhouse gases. So, for that purpose, on the y axis it is said that the greenhouse gas emission in terms of gigatons of carbon dioxide equivalent per year. Okay. So, look at this. So, it has been shown at a decadal scale. Since this figure has been taken from the 2022 report, by that time the 2019 observations were there. So, were completed. So, taking from 1990 to 2000, 2000 to 2010 and 2010 to 2019, and more specifically a dissection of 2019 scenario. So, look at this on the y axis. So, it is going up to 60 in terms of gigatons of carbon dioxide emission or carbon dioxide equivalent emission per year, and here you see 59% is coming from the carbon, 59% is coming from the fossil fuel and industry, and that becomes 61, then 65, and exactly in 2019 it becomes 64. So, 65 to 64 is a reduction at a time frame of a decadal or 9 years decade. So, 59, 61, 65, then you have a reduction. Now, look at the next one, that is the net carbon dioxide emission from FLU sector or agriculture, forest, land use and forestry sector. So, in terms of net, you can see 13%, 12%, 10% and then it is 11%. So, 10 to 11 is marginal increase, but 12 to 10 is a decrease and 13 to 12 also is a decrease. So, you can see there is a decrease in this sector. Coming to the methane emission has been increased, has been decreased from 21% to 20% to 18% to 18%. So, 18 to 18 is almost nearly constant. So, this much in terms of the emission coming from the methane over past 3 decades. Coming to nitrous oxide, 5%, 2%, 5% and again 4%. So, last decade 5 to 4% is a decline. And as far as the next one, that is the fluorinated gases is concerned, 1%, 2%, 2% and 2%. So, in last 2 decades it has not increased much, but there has been increase between 1990 to 2000. So, in absolute term 38 gigatons as far as 1990 is concerned, it went up to 42 gigatons by end of 2000. So, 4 gigaton absolute increase and then 53 gigatons, very high increase, 13 gigatons in the first decade of this century, 2000 to 2010. Then 2010 to 2019, it is 6 gigaton increase, 53 to 59. So, the pace has decreased. So, if you take it in terms of the rate, so you see 0.7% between 1990 to 2000, 2000 to 2000 it becomes addition as per in terms of 2.1%. and in terms of past decade 2010 to 2019 it became 1.3% per year. So, that is the rate that is, so what we mean to say, the greenhouse emissions slowed down in last decade from in comparison to the previous decade, which was 2.1%, and in last decade or past decade between 2010 to 2019, 19 years, the average has come down from 2.1 to 1.3% in terms of annual scale. So, the point is very clear that the greenhouse emission has slowed down in last decade. So, still continued rise in greenhouse gases. It has slowed down, but it has not completely stopped. There has been decline, but it is still continuing. So, that again is the cause of worry. Greenhouse gas emission continued to rise to 2019, so 2019, although the growth of global greenhouse gas emission has slowed over the past decade. It has slowed down, but it has increased. It is continuing to rise. That is one worry. Second, global net anthropogenic greenhouse gas emission during the decade of 2010 to 2019 was higher than the previous time in human history. So, that has been a hottest or the largest emission as far as the greenhouse gas is concerned during the second decade of during that period. Then coming to emission growth has varied, but has persisted across all groups of greenhouse gases. So, there has been variation, but it is more or less a kind of persistent variation. Cumulative net carbon dioxide emissions over the last decade, that is 2010 to 2019, are about same size as the remaining carbon budget to limit warming to 1.5 degree centigrade. Look at this rise what has happened in the second decade of this century between 2010 to 19. This is almost the same as you talk about limiting it up to 1.5 degree temperature rise. A growing number of countries, several countries, they have achieved greenhouse emission reductions over a period of longer than 10 years. A few at rates that are broadly consistent with global rates described in climate change mitigation scenarios that limit warming to 2 degree centigrade, that means 67%. So, many of these countries, they are persistently trying to reduce the greenhouse gas emissions. So, a carbon intensity improvements in the production of traded products has led to a net reduction of carbon emissions embedded in international trade. So, that is a good news. So, in terms of the carbon intensive, so the traded products, they have become more in terms of the low carbon kind of thing. So, that is a good news in terms of the trading and the produced materials. Look at the sign. The title is Sign of Progress, but continuing challenges, as we discussed with the help of previous two slides. So, there have been sign of progress, decrease, but it is still continuing, it is not stopped. So, total anthropogenic direct and indirect greenhouse gas emissions for the year 2019 in terms of gigatons of carbon dioxide equivalent by sector and subsector. Here is the depiction in terms of the division. So, in terms of division with respect to the year 2019. So, 2019 the emission was 59 gigatons of CO2 equivalent, okay, in that year. So, if you divide it into different sectors, in terms of building sector, this helps in knowing that which sector is emitting how much. So, building is out of 59 gigatons of CO2 equivalent, building sector is emitting 5.6 in terms of percent out of 59 absolute, right. Transport is emitting 15%. the FLU sector, agriculture, forest and other land use, okay, they are releasing about 22%. The industry is releasing nearly 1/4, that is 24%. Then the other energy sources are releasing 10%, and the electricity, heat and all these are releasing 23%, out of which the direct and indirect and in terms of various things are here. And so, this is the sector wise depiction as far as the direct emission is concerned. Now, let us see the sector particularly in terms of electricity and heat. So, energy systems 8.5% out of that 23, the and the industry is this much, FLU is 0 and transport and building and all these things. So, now let us come to the direct and indirect emissions. Building, as you know, the direct 16% and transport 15%, the direct emission as far as FLU is concerned 22%, direct from industry 34% other. So, the different breakup is written there in terms of if any of you wish to exactly know how much is coming in terms of the biomass burning, how much is coming in terms of the manure management, how much is coming from the rice cultivation, how much is coming from the managed soil and pasture. So, this says or this indicates the division in terms of the emissions emerging or coming out from different sectors broad in a different broad sectors. Now, what are the continuing challenges? So, and the sign of progresses. In these 3 boxes, what has been mentioned are the rate of global greenhouse gases growth has slowed in recent years from 2.1 to 1.3, we discussed it. But as far as the continuing challenge is there, the greenhouse gas emission have continued to grow at high absolute rate, okay. Absolute rate has increased. So, 40 to 59 in 30 years, close to 30 years. So, almost 1/3 increase. So, it's not a good news. So, continuing challenge, emissions increased by 8.9 gigatons equivalent from 2000 to 2009, 6.5 between 2010 to 2019. So, that has in terms of absolute is 59, we just discussed. The second is a growing number of countries have reduced both territorial carbon dioxide and greenhouse gases and consumption based emissions in absolute terms for at least 10 years. But the challenge is a combined emission reduction achieved by some countries have been totally outweighed by rapid emission growth elsewhere. So, if some, because we are in a globalization, so if somewhere it is decreasing, but in somewhere else it is huge emission. So, that is almost what you say outweighing whatever you have reduced in terms of emission in some part, this is outweighing somewhere else. So, that is also giving us a continuing challenges. So, let us say particularly for among the developing countries that have grown from a much lower base of per capita emissions, uncertainties emission levels and changes over time prevents a precise assessment of reductions in some cases. So, that means the per capita emission of developed countries remain high, particularly let us say Australia, Canada and US. So, per capita emission is very high in many of these countries. The third point we want to bring it out here is the lockdown. The lockdown policies in response to COVID-19 led to an estimated global drop of 5.8% in CO2 emission in 2020 relative to 2019. Good news. So, good news means lesson to be learned. So, and also it is well proven that if we slow down activities, the anthropogenic induced activities, then perhaps the emission, the CO2 equivalent emissions are reduced, and the proof is this. Lockdown policies in response to carbon dioxide led to an estimated global drop of 5.8% in CO2 emission in 2020 with respect to or in comparison to the previous year, that is 2019. So, energy demand reduction occurrence across sectors except in residential buildings due to teleworking and home schooling. So, a lot of things we did from in-house. The what you say online systems have come up in terms of so that has contributed in terms of reduction in the transport or the movement on road. Students or school children, they read from their home. So, that using online platforms, and lot of teleworking kind of things as far as the work is concerned have started. The transport sector was particularly impacted and international aviation emission declined. Look at this, the international aviation, because we stopped lot of flights, it has declined by 45% in comparison to the previous year 2019. So, this is well proven that we are the culprit, but what are the challenges? Atmospheric carbon dioxide concentration continued to rise in 2020 and emissions have already rebounded. So, when we again started, when the lockdown is eased, it is again rebound. Economy recovery packages currently include support of fossil fuel industries. So, we have started supporting the fossil fuel based industry. So, whatever drop in terms of the CO2 equivalent emission was there, post 2020 it again I think again returned. That means more of the emission have again started taking place, because we have supported a lot of fossil fuel based industries to speed up the economy or the economic activities what has made a fall during 2020 or the pandemic time. The scene is the indication is clear here. It is plotted up to 2020. Look at the global carbon dioxide emission and the impact of economic and geopolitical events. Particularly on the left hand side, it is the CO2 emission in terms of gigatons of CO2 per year, and look at the curve at exactly at 2020. Look at the curve exactly at 2020. You will find that there the curve has declined. So, 2019 in compared to 2019, the curve has declined in 2020, because that is the year where the lockdown happened. So, COVID-19 pandemic triggered both the global economic contraction as well as carbon dioxide emission reduction since the World War II. So, major break, particularly in the spring 2020 in emission trends, in which carbon dioxide particularly emission have declined by 5.8%. Daily emissions determined through activity and power generation data were decreased during the economic shutdown period compared to 2019, especially for the month of April 2020, where almost activities were close to null. So, this kind of the COVID lockdown pandemic or COVID-19 pandemic has given us a lot of information in terms of slowing down, in order to say that, in order to prove that we are the culprit in terms of anthropogenic induced emissions. Similarly, in terms of the sector wise dissection also, you see for this period in terms of 2020 versus 2019. So, if you see January, April, July and October, there have been decline in terms of the rise or emission from all these sectors. Look at aviation sector, look at industry sector, land transport sector, power sector, residential sector and total. So, in the month of April, there have been a decline everywhere in terms of the change in the global daily CO2 emission in terms of megatons of carbon dioxide per day. So, this has been plotted, and focus on the month of April, you will know that there are a lot of almost activities were null, and it has shown the sign of progress, the sign of less emission in terms of CO2 equivalents. So, coming to the next, the illustrative mitigation pathways, abbreviated as IMP, the explore different possibilities of evaluation of future energy and land use and consequences for greenhouse gas emissions. Each IMPs have a storyline. The key characteristics of the pathway are given in a kind of qualitative way. So, quantitative is selected from the literature on long term scenarios to effectively represent the IMPR illustrative mitigation pathways. So, two additional pathways you can see along with that are the CUR pole, that is the two additional pathways with respect to higher emissions are current policies, and the second one is with respect to the moderate action. So, look at the C1, C2, C3, C4, C5, C6 and C7, C8. So, you move from C1 to C8. C8 is a more pessimistic scenario in terms of exceeding warming of 4.4 degrees centigrade, and C1 is a very optimistic scenario where limiting warming to 1.5 degree with no or limited overshoot, and these mitigation pathways gives us that we have options in terms of coping with the situation of various warming levels. So, mitigation pathways that limit 1.5 or 2 degrees centigrade involve deep, rapid and sustained emission reductions. So, pathways following current NDCs until 2030 reach annual emission of 47 to 57 gigatons of carbon dioxide. So, this in terms of nationally determined contributions, and thereby making it impossible to limit 1.5 degree. So, pathways accelerating action compared to current NDC, nationally determined contributions, that reduce annual greenhouse gases to 47%. As far as the mitigation pathway is concerned, peak warming is determined by cumulative net carbon dioxide emission until the time the net zero CO2 together with warming contribution of other greenhouse gases and climate forces at that time act. So, the pathways that limit warming to 2 degrees centigrade or lower exhibit substantial reduction in emission from all the sectors. And as far as the mitigation is concerned, the stringent emission reduction at level required for 2 degree or 1.5 degree are achieved through increased electrification of building, transport and industry. Consequently, all pathways entail increased electricity generation, limiting warming requirements, shifting energy investments away from fossil fuels and towards the low carbon technologies. So, in nutshell, the mitigation pathways that limit to 2 degrees centigrade, it will entail losses in global GDP with respect to reference scenarios between 1.3 to 2.7. Yes, there will be an impact on the global GDP if we are investing in terms of the mitigation pathways. And we have taken the material from this third or working group 3 report. The reference is here, and to conclude, we have covered these 3 major things which is emerging. Emission reach at a point of challenge for various sectors. We found that the COVID-19 scenario has taught that there is sign of progress, but still challenges are remaining across sectors, and there are point of challenges in various sectors. COVID-19 has triggered both economic contraction and emission reduction. It is very well proved and quantitatively discussed. And mitigation and development pathways opens various implemented policies and trends. So, in general, let us see in our rest of the 4 classes in this week that how various mitigation development paths open various implemented policies and trend. So, in nutshell, COVID-19 is a good demonstration of sign of progress and sign of decline, and also says that there is challenges still lying, and the action in terms of coming or dealing with the mitigation pathways is in our hand. So, we need to act, we need to we need to invest, and we need to act fast, so that we can mitigate these climate induced challenges. Thank you very much.